Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture I am going to explain some problems on hydroboration oxidation reaction on alkenes. In short, HBO reaction on alkenes. Before that I will explain some important points on this topic. Please listen. Now what is hydroboration reaction? Addition of borane means BH3 across carbon-carbon double bond to form alkyl borane is called hydroboration. Here reagent is diborane means B2H6, or on the arrow you can write borane THF. Everything I will explain. And oxidation step after hydroboration, next step is oxidation. For oxidation, here reagent is hydrogen peroxide in basic medium OH minus. Now what is borane? Borane is this one. Now here boron atom is having how many electrons in its valence shell? 1, 2, 3, 4, 5, 6. So boron atom is having 6 electrons in its outermost shell. So in BH3, boron atom is electron deficient. It is having 6 electrons. Therefore, it is electron deficient. So, to get stability, borane forms dimer, which is B2H6, means diborane. Or you can use borane THF, that complex. Since boron atom is electron deficient, so what will happen? This is THF, tetrahydrofuran. This is tetrahydrofuran. Here oxygen is having lone pair of electrons, so it can be given to boron atom here. And this complex is BH3-THF complex. So this is commercially available. You can directly purchase this one, or you can use diborane, which will form BH3 and it will perform the reaction. Now see, this is alkene, propene. Alkene is having double bond, so it is having pi electron density, and borane is this one. Here boron is electron deficient, so what will happen? Reaction takes place between these two. Since boron is electron deficient, so it is electrophile. Now what is about the polarity of this bond? Since boron is electron deficient, so it is having delta plus charge. It is more electropositive than hydrogen. So note down this line, boron is more electropositive than hydrogen. So this bond breaks. This bond will also break. So here carbon is having partial negative charge. So it will react with this positive center, and this will attack on this carbon. It is because it is having partial positive charge. Since methyl is having plus I effect, so bond cleavage you have to show in this direction, and all the bond cleavage takes place in a single step, means it is concerted step. So reaction takes place via this cyclic transition state, and we are getting this hydroboration product. So what is happening? Since the bond is breaking in this direction, so this carbon is having partial negative charge. So here partial positive charge is attaching here, and since this carbon is having partial positive charge, so this H minus is adding here. So here addition is taking place according to Markovnikov's rule only. Similarly, other two hydrogens will also be replaced by alkyl group, and we will get trialkyl borane. So total 3 molecules of alkene are required. So after that what will happen? For oxidation, hydrogen peroxide in alkaline medium we have to treat, and here we will get CH3, CH2, CH2, and where boron atom is attached, at that place by oxidation we are getting OH. Mechanism in detail I am not showing. So finally addition of water means hydration is taking place here, but see, final product looks like anti-Marconic of addition of water, where OH minus will attach with the carbon which is least substituted, and H will be attached to the carbon which is more substituted. So final product looks like anti-Marconic of product. Another thing you can say here, boron will be attached to that carbon which is having less steric crowding. So here this carbon is having less steric crowding, so boron will be attached here. So here we will get only oxidation product, means OH will come here only. So that thing you have to remember. When you are using diborane, at the first step you have to break this one to form the monomer, and from monomer you can show the reaction. Another thing, here syn addition is taking place. H and BH2 will attack at the same side of the double bond. So here syn attack is taking place. Since the reaction is taking place via cyclic transition state, not via carbocation intermediate, so here no rearrangement takes place. To write the final product, you have to follow anti-Marconic rule. Means OH minus will be attached to that carbon atom which is having lesser number of substituent. These are high selective reaction. Here boron atom is bound to the less highly substituted carbon atom. Less highly substituted carbon atom means where hydrogen atoms are more. Now see, this is propene. Here one hydrogen atom of the double bonded carbon is replaced by methyl group. So it is mono substituted alkene. For mono or disubstituted alkene, you will get trialkyl borane. For trisubstituted alkene, you will get dialkylated borane. This is trisubstituted alkene. So here you will get dialkyl borane. Means in borane, two hydrogen atoms are replaced by these two alkyl group. And in the final product, H is coming from borane and OH is coming from H2O to OH minus. From 3 molecules of alkene, we are getting 3 molecules of alcohol, and here we are getting boric acid. OH minus will attach with that carbon atom which is least substituted or which is having greater number of hydrogen atom, and H will be attached with that carbon which is more substituted or which is having lesser number of hydrogen atoms. You have to remember these points. So find out the products. First problem, we are having this alkene. In this alkene, this double bonded carbon is having 2 hydrogen atoms, so it is unsubstituted, and here one hydrogen atom is substituted by this alkyl group. So this is mono-substituted. So here by treatment with borane, what will happen? This bond will break, and where there is less steric crowding, there BH2 will be attached, or you can say where there is lesser number of substituent, there BH2 will be attached, and where greater number of substituents are there, where H will be attached. So we will get CH, here CH2, BH2, and here hydrogen. Then it will react with another 2 molecules of this alkene to form this trisubstituted. Borane, trialkyl borane. Now if you are treating this with H2O2 OH minus, so here OH will come we will get this product. Here you can write on the arrow 2 molecules of this, I am not showing. So in the final product, OH will be attached with that carbon which is having lesser number of substituent or greater number of hydrogen, and H will be attached with that carbon which is having greater number of substituent or lesser number of hydrogen. Now for this example, what is the product? Final product now I will write. Here deuterium will be attached, and here OH from this oxidation reagent will come and attach. So this is your product. So for the next, here we are using boron, and here deuterated hydrogen peroxide and OD minus is there. So from here OH will come. So if you follow the mechanism, from boron hydrogen will come and attach, and from this part OD will come and attach. If both are deuterated, then here also deuterium will come. For this is also monosubstituted alkene. Here final product only I am writing. So from boron, here you will get hydrogen, and from this oxidation reagent, here you will get OH. And since reaction is taking place via 4-membered cyclic transition state, no carbocation intermediate is formed. So there is no chance of rearrangement of carbocation because carbocation is not generating. This is disubstituted alkene. So here first you will get monoalkylated, then you will get trialkylated boron. So in the final product, here you will get OH, and here you will get H. At the more substituted end, you will get H, because from boron hydride is coming here. Now for this, H will attach with the more substituted carbon, and from here OD will attach with the less substituted carbon. So what is the final product? Here from here OD will go, and here from boron H will be attached here. So we will get this 2-methyl cyclohexanol. In this video till this, if you like, please subscribe. Thank you for watching.